This paper will examine the electric field strength in the cable and its various components. In particular, we will explore the relationship between the cable's length and the electric field strength. Additionally, we will study how the presence of materials such as metal or insulation affect the electric field strength. Finally, we will investigate the impact of the mutual capacitance of two cables on the overall strength. This paper looks at the electric field strength in an electrical cable. The electric field strength is a measure of the electric force per unit charge that exists within the cable. It is important to note that the electric field strength is not the same as an electric intensity. Since the electrical force depends on the charge of the particles, it is important to have a way to quantify both the charge and the electric field. Electric fields exert forces on charge carriers inside of conductors and can thus be used to control their movement. In order to take advantage of this concept, engineers must understand the field strength in cables. For single and multi-conductor cables, these electric fields are modified depending on the distance between the conductors and the electrical properties of the insulating material encasing them. For example, in a coaxial cable with a diameter of 6 mm and a dielectric constant of 2.5, the electric field strength is typically 8.7 kV/m. The electric field strength in a coaxial cable is affected by different parameters such as insulating material, distance between conductors, and conductor size. Electrical cables have been a part of our society for centuries, but it wasn't until the advent of electricity that their design and construction began to heavily impact our lives. Electromagnetic forces within the cable cause an electric field to develop, and its intensity is known as the electric field strength. The electric field strength in a cable can be influenced by a number of factors, including its location, surrounding environment, and the amount of voltage used. Knowing the electric field strength of a cable is important because it can provide insight into how efficient the flow of electricity is within the cable. The electric field strength in the cable, or ELF, is an essential factor when considering data transmissions, as it is essential for understanding how much data can travel through the cable at a given time. ELF is determined by the current magnitude and the resistance of the cable. The higher the ELF, the more data can travel faster in the same volume. ELF also helps to protect the system from voltage surge, thereby providing additional security to the network.